Hello, welcome back. We're looking at introduction of calculus. Last videos we looked at the first principles, the idea of where calculating the gradient comes from. Well, we're going to be looking at some simple rules to making finding those gradients much easier. And we've got these 4 simple rules up here that are going to be what we're going to use in the next few videos to find the gradient of a function that we can use in calculus. So let's have a look at each of these equations or these rules, break it down a little bit of theory, look at it, and then we'll look at some examples. So let's look at this first one. We've got y is equal to x to the power of n. Okay, so if we had, for instance, an example here, let's write the example y is equal to x to the power of 4. Well, what we're doing here is we're going to be taking this number 4 and we're going to multiply it with the coefficient of x at the front. And once we've done that, we take 1 away. So, in essence, this is what the answer here becomes. It becomes nx n minus 1. But if we looked at the example, y, and this here actually becomes dy dx, let's just write that properly. If we looked at this example here, this then will become dy dx is equal to x to the power of 3, or 4x to the power of 3. And that's our most basic form. What we're doing here basically is multiplying the power to the front, and then subtracting 1 away from that power. So if we look at this second example, if we have that second example here, a being a value that's different to 1, okay? So we can write an example here, we might have y is equal to 5x to the power of negative 2, okay? I've chosen negative 2 because this here is an example for what we're going to be doing in terms of making sure we don't make these simple mistakes. So we do the same thing as we did at the top. We're going to bring this negative 2 out, and we're going to times it by that power, by 5. And then we take 1 away. So in essence, the general formula for this here would be dy dx is equal to nax n minus 1. So this here is the derivative of that general formula. However, if we have this example here, the derivative, this would be dy dx is equal to, well, negative 2 times negative 5 is negative 10 x. Now, be careful here. Negative 2 take away 1 will give me a larger negative. What some people do here is they'll do negative 2 take away 1, and in their head they go, 2 take 1 is 1. That's got to be negative 1. But don't get fooled by that. Let's have a look at another example here. Let's have a look at, before we get to C, I want to have another look at an example I haven't got up here. If I had, for instance, y is just equal to x, and I wanted to differentiate that, okay? What am I assuming is up next to the x? Well, I'm assuming there's a 1 there. If I'm assuming there's a 1 there, then I'm going to multiply by 1 and then take 1 away. So what I'm essentially getting here is I'm getting x, 1 take 1, which is the same as x to the power of 0, which is the same as 1. So therefore I get 1 times 1, which equals 1. So dy dx is equal to 1. And that happens to any function. If I had 5x, okay, I take 1 away from here, I get 5x to the power of 0, which just gives me 5 times 1, which gives me 5. So anything that has a power of 1 next to it is always going to give me a constant. Where in these cases here, I'm not going to get those constants. I've been looking at examples where the power is greater than 1. So let's have a look at the next rule. Where have I put, where is it over here? The next rule is when you have a constant. Well, I'm going to show you here, if we had a constant, and just say we had y is equal to 4. And that's it. There's no x value there. Then over here, dy dx would equal 0. And let's explain that to you here by just using a bit of a graph. If I sketch a graph here, we know that the blue line is a positive gradient. We know that the black line is a negative gradient. And we also know that if we have a straight line, then that is a 0 gradient. So remember, when we're looking at differentiation, we're finding the gradient of that function. So if we have a constant, y equals 4, and let's say this here was 4, well, I'm only going through the y-axis and it's a horizontal line forever, ever, ever, ever. That means that the gradient of this horizontal line is 0. It's neither going up or going down. So therefore, anytime you have a constant in your equation and you're differentiating, the answer just becomes 0, so it doesn't exist. The gradient is 0. Now our last example is, well, once we have f of x plus g of x. So this here just becomes dy dx is equal to the derivative of f of x plus the derivative of g of x. So what do I mean by that here? That means that I'm differentiating, if I have more than one term, I've only got one term in each case, but if I've got more than one term, I just differentiate each term separately. So if I have y is equal to 2x squared plus 4x, all I'm doing here is just differentiating each term separately. So this here would be f of x plus g of x. So therefore, dy dx would then become 4x plus 4. So I differentiate this to get this, and I differentiate that to get 4. And that is the four different rules that we use when it comes to simple differentiation. The next video we're going to do is we're going to look at some examples. But before we get to that, we'll do that in the next video. I'll see you next one.